Hey guys, it's Mrs. Bryant. Welcome back to Flip Classroom. Today we are going to be talking about unit rate and how it goes with slope. So go ahead and get out the paper I gave you in class today about unit rate and slope. And once you have it out, you may press play and we can begin. It says a snowstorm is taking place on Snow-Capped Mountain. The graph below shows the constant rate of change of the snow level on the mountain. And it is asking us to determine the slope and to find the constant rate of change. Rate of change, you know, is change in y over change in x. And we can determine the slope of the line from the graph. Remember, we have rise over run. So take a starting point. I'm going to use these 2 points, so I'm going to rise. I'm going to rise 1, 2, over run, and I'm going to run 1. So I can write a positive 2 here and a positive 1 there. So my slope is 2. To find the rate of change, we need to go ahead and fill out the table. So I'm going to use 0, 0, and I'm going to use 1, 2. And I got these points from this point, which is 0, 0, and this point, which is 1. You travel 1 and then up 2. Now to find the rate of change, you need change in y. So change in y would be positive 2. Change in x would be positive 1. So you come down here, your change in y is 2, and your change in x is 1, so that simplifies down to 2. We talked about yesterday in class that the slope of a line and the rate of change would be the same. We found that on the sheet that we did in class. So now it wants to know how much it snows in 1 hour. So to determine the unit rate of snowfall, I'm going to go ahead and fill this back in. We use y divided by x. So I don't care which one you use. But make sure you circle it or you highlight it. Can we use 0, 0? No. So you need to make sure that you highlight one that actually has numbers in the x and y position. So let's go ahead and find our unit rate. Y would be 2, and your x is 1, so that simplifies down to 2. And it says, how can you determine the unit rate by looking only at the graph of the line? Well, to answer that question, you know your x has to be 1. So you would go to 1 and then follow it up to where it hits a dot, and you know it's 2. So go to the 1 on the x-axis and go up or down to where it meets the line. All right, so we can go ahead and go to another example. or let's talk about this. What do you notice about the slope, the rate of change, and the unit rate? On the instructions it says compare the slope of the line, the rate of change, and the unit rate. And what do you notice? What you should notice is that all three values or quantities are the same. Then it asks, why do they all have the same value for this situation? It's because it is a linear equation. So, in a linear proportional relationship, the slope, rate of change, unit rate, and constant of proportionality, and we talked about constant of proportionality. Remember, that is k equals y divided by x, all have the same value. A quick way to find the slope, rate of change, unit rate, and constant of proportionality in a linear proportional relationship is to determine the y value of the ordered pair that has an x value of 1. You need to make sure that you understand this statement and this statement, and they are on your notes, so you're not having to write it down, but you need to make sure that you understand what those mean. So let's do another example. A chairlift at Snowcap Mountain travels a distance of 30 feet every 4 seconds. Complete the table to describe this relationship. Okay, so in 4 seconds it travels 30, so in 8 seconds it would travel 60. 30, 60, 90 is skipping by the same amount or changing, so 4, 8, 12, 16, 20. So then you have 30, 60, 90, 120, 150. Determine the unit rate in feet per second, and to do that you take y divided by x, and again use a highlighter, circle something, but you need to choose which one you're going to use. So I am going to use that one. So I have 30 divided by 4, and when you simplify that you have 15 over 2, or 7 1/2. And what does that mean? It means it means it travels 7.5 feet per second. It says to predict the slope of the line that represents this relationship. So your slope would be 7.5, or 15 over 2. We like to keep slope in a fraction form because it tells you how far to travel up and how far to travel to the right or to the left. So now we can graph it. It says graph the relationship. So in 1 feet, or 4 feet, or 4 seconds, it travels 30 feet. So you put a dot there. In 8 seconds, it travels 60. 12 seconds, it travels 90. 16 seconds travels 120. And 20 seconds is 150. Our process would be 15 over 2, right? Yes, so if we had a 0, it's multiplicative, so it starts at 0, 0. So connect your dots. And again, I apologize for my non-straight line. But now it says find the slope of the line graphed. Well, take your 2 points. We're going to change it up a little bit. We read left to right in America, so start with your leftmost. And you notice I'm going to go up, so that's 1, 2, so plus 2. And then I'm going to run 1. I'm sorry, that's 10. That's 30. Let me erase that. Does everybody know what I did wrong? I didn't pay attention to how it was skipping. So I'm going to use these two. And so 15, 30, so you have positive 30. And then you're going to run. And it's skipping by 1. So 1, 2, 3, 4. So plus 4. So you find your slope by rise over run. And we rose 30 and ran 4. And that goes to 15 over 2. Was our prediction correct? Yes, it was. So it says, describe what the slope means in terms of the situation by completing this statement. It says, the chairlift travels blank amount of feet in 1 second. Well, 7.5, 15 over 2, 7.5, they're all the same. It travels 7.5 feet per second. That is the end of the video. Make sure you have glued this in your ISN, and we will practice using this skill in class tomorrow. Now, to make sure you are watching the video, it is your responsibility to make a comment. Whether or not you like the video, whatever, you need to put your name or something in the comments below so I know you watched the video. If you have any questions, you can leave questions in the comments and I will get back to you. And that is it for this evening. I will see you in class tomorrow. Have a good night.